Oh, I didn't notice you there. You're probably here for the video about the HomeLAB. I'm always very interested in computers, in this one, but also in the servers that I run very often. So this video is mostly about my HomeLAB, how it's set up, the network I have inside of my house, and the computers and the different software that I've set up on top of that. This is all a bit of a combination of things that I've been doing the last couple of years, especially the hardware, which is 2 years old, and things that I've learned in all my life as working on computers and things like that. So here we go. Here we have the main power cabinet of my house. Up there you can see I have 1 gig fiber coming in. This is going into an edge router, and then the switch on the left here, this is a PoE switch, and this goes to my front doorbell because that runs on PoE. And then also the other white thing, that is for my CV system, my central heating system. So the edge router then goes to a 2.5 gig switch here. So everything that's data is actually going through the switch. So everything is 2.5 gig from here. The switch actually has the same power supply as my router, because I've spliced those together. You can see that there. Those are the white connectors. Those are spliced together just to save a little bit of power. Most of the connections go through patch cabinets, and this goes to different places inside of the house. So you've got the doorbell, of course, then you have my attic, which is the green one, and then my office, the purple one, and then the gray and yellow ones are going through my living room, and those are also the orange ones. So those actually go all the way underneath into the crawl space, all the way down. And there's 2 connections there actually. One of them goes to the switch there, and the other one goes directly to my gaming PC, because the switch is only 1 gig and the gaming PC is 2.5 gig. The switch here, you can see there's then 2 more connections, and those 2 connections go to the NAS and my VM server. It was quite tricky to fit these inside of this cabinet. So what I did is I made like this wooden piece here, and I screwed it into the door, and it fits absolutely perfectly. So if I close it like this, you can see it just fits. It fits just above there. It doesn't touch anything. So overall, I'm pretty happy with this. This white part here, you can see these are power meters. And then this thing here, this is actually a small device that connects to my power meter, and I use that to log all the data. All the data goes into HomeLAB. So here we have the living room. Everything kind of comes in here. It's kind of a bit of a mess. You can see the orange cables in the back there. Those come in, and then we have a PoE switch here. Well, it's half of it is PoE, and the other half is just normal connections. So this Unify is PoE that gets connected here. This is my Philips Hue bridge, and it's connected to a PoE converter. And this is a NVIDIA Shield TV, and one of those connections actually goes to my computer on the left, and then also there's like a doorbell screen that's also PoE. Actually, I can see that the tape is actually not really holding on. It's holding with dear life. Not really often in this cabinet, because everything just works here. And you can also see in the back there that those are speaker cables, and those actually go into the crawl space as well. This is for the back speakers. Wi-Fi. But yeah, the Wi-Fi is just under it, so. And here you can see the cable that comes out there. And I'm in the office right now, so in the office one cable gets used, 2.5 gig. And then the other cable goes all the way up there for the attic. I'm in the attic right now, and the cable goes under here, and it goes to this switch. So this actually connects some whatever I have running in the attic. I have a printer here as well, and then under here you can see this is the Wi-Fi access point. So I have two Wi-Fi access points, one all the way in the top of the house, and the other in my living room, and that kind of covers the whole house pretty well. There's also some other projects here and 3D printer, lots of stuff here. Alright, let's start with the NAS then. So these are the specifications. It's ASRock B660M, it's an LGA 1700. It has an Intel i5 12400, 32 gigs of RAM. It has three 16 terabyte drives, and then it has two 4 terabyte SSDs. So the SSDs are used for anything that I need fast storage for, and then the storage on the hard drives is for just long-term storage. The SSDs are in a mirror configuration, and then the three hard drives are in a ZFS RAID Z1. So if one of them breaks, then I still have all of my data, but there's just one. It's in a fractal node 804, and right now it has the 550 watt power supply, but this is something that I actually changed a bit later on. So the system is about 2 years old now, and I have made, I think, just one difference. It's just the hard drive that has changed. So this is an overview of the case, and then in the back I have the hard drives, and then in front, of course, it's just the system. This is the front part then. I think these fans are still in, but I disabled them because they use too much power compared to the rest. And here you can see the hard drives, the SSDs. This is like an in-between setup. And here you see me putting in new power supply. This happened a bit later, I think 1 year ago. And here you can see the configuration for the SSDs. So I think I 3D printed like an adapter for 3.5 inch to 2.5 inch. And then both of the SSDs are on top of each other connected to that. And in this way, they all get airflow from this one fan. So this is the only fan that actually runs all the time. I would say the only thing really about this is the motherboard. This is the ASRock B660M Steel Legend, and it didn't really support power saving correctly. So I had to disable most of that stuff. And also for hard drives, I'm actually not really letting them spin down. So they're constantly running. But these Seagate drives are already equipped with their own power saving features. So they already run slower, they already power manage themselves. So it's not too bad. I think this whole system uses about 30 to 35 watts in idle. And this is also with the NVR running. So the iGPU is also running. Could I get it to maybe 25 watt, maybe 30? I think so. With a different motherboard, I might have even be able to go lower, maybe even 10 or 15. But this is kind of the thing where if power saving features are not supported well, then the CPU cannot go into that low power state mode. Okay, so let's talk about the software then. So the system is running Debian, and I chose Debian because it's kind of bare metal, something simple and fast and also stable. I did look at TrueNAS, and I even installed TrueNAS for a little bit, but while the ZFS stuff was great, even back then, 2 years ago, it was using K8S, so it was using a lot of extra power just for that K8S. And also, I just could not understand ACLs at all. And I'm a single person using the system, so the access list is not really that important. But I've been pretty happy with Debian. It's been pretty stable. What you see here is Cockpit, which is running on top of it. It's kind of like, it is an exception, and I was just talking about I don't like abstractions, but this is a pretty light layer, so it's pretty clear what's happening. I can also do a lot of stuff in the command line, but it's really nice to be able to test stuff, and especially if I want to see, right, so how's the ZFS setup doing? How much space do I have? There's a command for that, which is just the information that you see here is almost exactly the same as the command, but it's just a lot easier to use it like this and to check it out. And also very nice to be able to see logs in an easy way and be able to filter them. This was instrumental for me with this system. And you can also see things, especially for debugging, you can see what's actually happening. This is the storage part. And also for setting up file sharing, it's just easier to use. I know the config files, it's all pretty much the same as what happens in the config files. It's just a little bit easier to use. And especially the logs were really important because that's how I was able to figure out what was actually going wrong with the power saving. So I was seeing a lot of these errors, and I was also seeing in the ZFS that errors and checksum errors, lots of checksum errors. And these were all caused by the power issues, by the Pico PSU, and also by the motherboard power saving features. And I was able to use this to figure all that stuff out. So I'm really happy with that. I've had no issues at all, more than a year running with the power supply. And the interesting thing is also that with this power supply, it's also a lot more quiet. The hard drives are a lot more quiet. So I guess there's something going on with the power delivery of the Pico PSU, about the power supply, and also the cable. But there's another video where I talked about that, so I'm not going to go into further now. And then on top of the NAS part, so here's also the sharing, of course. We have Samba for my computers and stuff, and then NFS for the other computer. I'm also running Portainer on it, and this is like I'm running Portainer, Docker on the computer, and then on the other computer I also have Docker Portainer agents that connect to this Portainer instance. So it allows me to manage everything from one Portainer instance, and I use this one because usually the NAS is going to be always running. It's going to be more running than maybe the VM PC, but that differs, of course. So I'm running Portainer here on Docker, and these are like some of the stuff that's running. And the way I set this all up is that I have a GitHub, and then on the GitHub I have these Docker Compose files, so I can just commit to this GitHub, and then in Portainer I can have it pull from my Git repository whenever there are changes made, and it pulls them out. And then I also have secrets, which is under here. I'm not going to show you, of course. There's also secrets. So if you look at this, for example, this YML file for a photo prism, you can see that I have secrets here set up, and then I will just fill them in Portainer, and in that way I don't have secrets inside of my Git repository, even though it's private. You don't want to have secrets in there, and then it's very easy to push changes. I don't change it that much, but whenever I'm working on something, maybe new application, it's very easy to push changes to that. So this has all been working really well. I'm really happy with it. And then one of the other stuff that I'm running is Duplicati. This is for backups. So I have backups locally from the SSD pool to the hard drives, just to have like a second copy. And then also, so this is like the photos and books pool. So this is just from the SSDs going to the hard drives, just to have an extra copy. And then I'm also pushing files to Backblaze. I think this is once a week, yeah, or maybe once a day. And I also have Backblaze just to be able to have like a second place where I have backups to. So this is the Duplicati setup on the NAS itself, which just does this, and then also local config. This is on the NAS, of course. The couple of applications I am running, it's not redundant. So when something goes wrong, I want to be able to pull back that stuff. I'm also running Plex on this on the server, and the reason I'm running Plex on this is, first off, is that it is directly on the same server that the data is on, and also that Plex, for Plex, I want to have a GPU acceleration for encoding, and that can be a little bit tricky in Proxmox, which is a different server. So anything that really wants to use that or is very data heavy, it's all on the NAS here, and Plex is as well, and it runs perfectly fine. And the CPU has a iGPU, of course, and that runs pretty well. So that's for Duplicati. And then this is NVR. This is also connected on the GPU, so it will detect changes and it saves it for a certain amount of time from my front doorbell camera. I'm also using Photo Prism, which is also, of course, data centric, and this is also running on top. I also use this to organize the photos, but it's still in a separate folder on the SSDs. This has also been running pretty well. My phone also just automatically backs up to that place, and then that continues on. And then I'm running file run, which is a bit like Nextcloud, but then maybe not as expensive. I know this is paid, but I was just having a lot of trouble with Nextcloud, and I'm also using this for business. So for me, it's fine to pay for something as long as it works. And file run just works. I'm using it as like a OneDrive Nextcloud. I sync my computers to it, and there's also this interface to be able to see it. And the nice thing about file run is that it supports actually a lot of different types of files that I can just preview. JPEGs, of course, are easy here, but lots of different files that I can preview. It's really fast, even for syncing. And of course, it uses WebDAV, which is not that quick, but it's even using WebDAV, it's just so nice to be able to sync things pretty quickly, especially OneDrive. I have a fast internet connection, but OneDrive is just so incredibly slow. So I'm really happy with file run and how it works. And then the last thing here is paperless. This is something I've set up. It's not 100% running yet, but this is for all of my documents to be able to find them, to OCR them, and then also to set them up and to catalog them. So everything on paperless is getting cataloged, and I'm actually using AI on my computer to first OCR them with machine learning, vision learning, and then also to fill in all of the information and metadata in paperless from that. Paperless has its own part, but I'm using that because it's a bit better. It's using larger language models. And it's really insane how I can just put some paper inside of my document scanner. It will upload it to a folder. Paperless NGX picks it up, and then it will just send out requests using like a different document container, and then push it all out again. So all in all, I think the NAS has been running pretty well apart from those issues. There's not really a lot I would change. The only thing maybe is that in regards to expandability, there is some expandability. There's one PCIe slot, of course, still available, but most of the connections are used up. All of the SATA connections are used up except one, I think, because it's 3 drives and then 2 SSDs. So then I only have, I think, 1 left or 0 left. So if I want to have like a graphics card, I would probably use it in this computer and not in the other computer. And if I want to have more storage, I probably won't be able to do that unless I have to choose between AI and extra storage with like an HBA. But overall, I don't think I would change anything about this. Debian has been running really well. Okay, let's talk about the second server. This is the VM computer. You can see some of the specs here. It has the Intel Core i5-13400, which has 10 cores and 16 threads, so it's actually quite powerful. It's a 65 watt, and it's in the Asus H610. This is a thin mini ITX motherboard and also a case, so it's a really, really small computer. It started off at 32 gigs, but I also upgraded it to 64 gigabytes of RAM. Did it really need that? I don't think so, but I had the extra RAM a year ago and it wasn't that expensive a year ago. It also has a 500 gig SSD and then 1 terabyte NVMe SSD. And here's the board. It's incredibly small. It's really just a really small and efficient system, especially when you put everything together. I mean, you can see here, I wasn't far enough yet here because this thing, of course, did not close correctly. And then also the front I/O also didn't end up working in it. And here you can see I kind of had to break away part of the SATA SSD. It kind of looks like I cut the PCB here, but no, this is actually this is all the PCB that is inside of this 2.5-inch SSD. And then also a cutout here to make sure that the fan fits. This is a Noctua small fan. And this is what it looks like. It's really small. You can just hold it in your hand like this, right? And it's on top of the NAS, but it's still really powerful. And the greatest thing about it is the efficiency. especially because the motherboard supports pretty much all of the power management features, and then also in Linux you can get that working. For me, I couldn't get it working in my setup, and I kind of gave up after a little bit because I just couldn't get it working and I was spending too much time on it. Especially if I was just using a SATA SSD, it would work, but in my case, it just wouldn't. It wouldn't get into the right power state with just the NVMe SSD and actually using the NVMe SSD. But I know some other people have had it working, and if you do have it working, this whole system will idle at 4 watts, which is kind of insane for the amount of CPU power that this delivers, right? I mean, even a Raspberry Pi is hard, including power supply, to get at 4 watts. And it has an external 19-volt power supply, and it will idle that low. Of course, it can use a lot more. It's a 65-watt CPU, but when you don't need it, it will just ramp down. And I think that's really amazing. So it's been running for a couple of years. Of course, the extra RAM in it, and I'm pretty happy with it. And what it's running is Proxmox. This is just for me to have like flexibility to run extra VMs and things like that. And I will sometimes spin up VMs to test something, and then I'll shut down the VM and then run it again. As you can see here, this is like the main interface. You can also see that the CPU is not really utilized as much. This is like peak usage. And RAM is also really not used that much. I haven't done any experimentation lately. So the way I've set up all of my applications running on top of it is I've made 3 different LXC containers, and in each of those LXC containers it runs a Docker agent. So Docker agent is connected to my NAS Portainer setup, which means I just have to log into one Portainer setup and I can manage all 4 different Docker systems in Portainer. That works really well. But I would suggest to not use LXC because it causes problems with Proxmox, especially when you have large files that are being transferred in between. The whole LXC container just becomes completely unresponsive, which is something you also see a little bit later on here. So I would change this to a VM. And back then, when I was setting this up, I was all about I want to have maximum performance, everything bare metal. And right now, I've kind of figured out, well, it doesn't really matter that much. This computer is also not really under much load, so having stability and things like that is better. But yeah, that's something for maybe later, maybe for next year. So the first one here is MediaNet. So I've separated them out to 3 different LXC containers, and the reason why is that I've given each set a small amount of CPU cores and memory, so that it cannot just use all of the memory and all of the CPU power of the whole system, which is very useful because then other things would also become unresponsive, and especially IoT. I don't want to have my home stuff to become unresponsive just because there's something else running. So you can see here MediaNet, it has 3 CPUs, and then WebNet has 2 CPUs, and IoTNet also has 2 CPUs, and the whole system has 10 CPUs of 10 cores. So in that way, you would never get overloading. Of course, you can still overload the memory controller, but at least in this way, I don't overload. I can't overload like a simple CPU process. So this is the MediaNet. And then if I go into Portainer, then these are all of the things that are running on it. So this is all also the same as the NAS. It also has stacks, and these are just Docker Compose files, and then that runs onto this. And I'm still logged into my NAS actually right now. You can see it here because these are just agents that are connected to that. So that's really nice. So MediaNet here, this is just like general media stuff. And then this is WebNet. This is everything that's connected to the web. Also, by the way, this is also made with a Proxmox helper script, which is really nice. It's someone else made. But yeah, of course, you should probably don't use LXCs. So for WebNet, I'm running these different Docker containers. I'll go through them afterwards. And then for IoT net also, I see I have to actually look at the boot disk because it's almost full. This is all my IoT stuff, like Home Assistant and stuff like that. You can see that here. All in all, this actually doesn't really use any power. If I would be really honest, I could probably just run everything here fine on my NAS. But yeah. I do have like some Ubuntu stuff and some other. I think I was also looking at GitLab, and GitLab uses a lot of RAM. But I just I couldn't really figure it out, and I've just kind of I've removed it again. And I've also sometimes ran game servers on this, and for game servers, of course, there's a lot of hardware there for the game server to run on, so that works well. You might be thinking that, well, this CPU, this is probably like one of those CPUs that have like the degradation issues, right? But actually, this 13400 is actually an Alder Lake chip and not a Raptor Lake chip, so it's not technically you should be calling this a 12400 plus, because if you look at the 12400, the 12400 has 6 P cores and then no E cores, and then this one has 6 P cores and then 4 E cores. It just has a couple of extra E cores, but that's all of the difference, and it's still the same Alder Lake, so no degradation issues there. So looking at the different applications I'm running, the first one is homepage. This is also my homepage. This gives me a nice overview of everything that's happening, and it also allows me to get into stuff that I want to see. It also has some extra links here. And this really, I wanted something light because I've tried some other stuff and that was not light at all. So it's nice. Then we have Nginx Project Proxy Manager. This is my reverse proxy. Well, the Nginx is the reverse proxy, and then this application manages it. I'm not 100% happy with this because it has some issues right now. I've kind of left it be because it works as long as I don't touch it. But this is something that I would probably do differently. Maybe I would just set up my own Nginx configuration files, because I kind of already done that here. So I'm using Nginx, and I'm also using authentication using Atelia. So I have to log in to actually access this. And this gives me some security when I'm accessing it from outside. And I've also had to set up, of course, the advanced proxy stuff here. So essentially, I could probably just do this with Nginx, and then also one thing I'm thinking of is using Traffic. If I would redo it, because it allows me to just set up the whole thing using Docker Compose as well. So then I just have like a very declarative setup. But for now it works. So Atelia, and then also I'm using Let's Encrypt. So my domain name is in Cloudflare, and with the domain challenge, I can make sure that SSL certificates are made for all of the stuff that is outside of my that when I access it outside, and also inside, because I've did a bit of a trick. So I have a domain name, and then of course when I'm from outside of the network, I can just access the domain name and then have an SSL certificate like that. And then for inside the network, I actually set up in my router a DNS, so that if I'm inside of my network, I can access anything inside of the network, because instead of the DNS referring me to my outside address, it will refer me to the inside address. So this is the inside address, of course, for WebNet. It will refer me to that, which means I just have a network connection. But because it's still a domain name, and because it's still going through the proxy, it still has an SSL certificate, and that is a valid SSL certificate, because what I'm pointing to is actually the point that also has the SSL certificate. So that works really well and allows me to have a quick access to this. So this is Atelia. This is just the authentication. I can have multiple accounts. It's just one account here, but you have multiple accounts. You can also set up that certain areas are available or certain areas are not available. But I'm not really doing that. I'm just making sure the access here. And there's also 2-factor for this as well. So that's pretty nice. Another thing I'm running here is OpenWebAI. This is like an AI thing for my AI models that I run at home. So I have my gaming PC connect in the network, and then this will just have API requests to my gaming PC, and then this will save all the prompts. And this also has some knowledge stuff like uploaded files and then embedded, and I can access it from here. So it's just an open WebUI Docker container. It's not that complicated. And then you have Unified. It's just a Unified controller which is running on it just to make sure that the Wi-Fi access points work correctly. You have Uptime Kuma. This is to make sure that when something goes down, you actually know about it. This can be a bit tricky. I used to have like a system where I didn't really know what's happening until I tried to access something and then it's down. And this is also connected to Telegram. So it will send a telegram to my phone and then I'll get a notification right away that something is going wrong. You can see it's also that today some stuff has been going wrong. This is all to do with the LXC containers. So don't use LXC containers for anything that has a lot of that has big file transfers, because yeah, that can cause some issues there. So the next one is Calibre. This is like my book setup. This is also Docker container for this. It actually just runs the normal application and then has like a kind of remote desktop kind of thing for Camoli, I think, to access it. I also have Code Server. This is like a VS Code inside of a browser, so I can sometimes access code through here if I want to check something out. And then also I use this often to edit config files of any of my applications that I'm running, that you can see here. It just makes it a little bit easier than having to SSH in and then having to vi, and yeah, this makes it a bit easier than that. On the server, I'm also running backups. So these backups are just all of the configuration. It gets pushed to my NAS, and then the NAS will also, of course, back it up further on. So whenever something happens with this computer, I can still get it back because there's no redundancy on this computer at all. And this only does the config, so it doesn't do anything like files that I've maybe downloaded or things that are on the server. It's just the config and the databases and stuff like that. There's still something I have to do here because backing up databases is kind of an issue, because of course when the database is running, you can't access the file that it's running from. So there's something that I still have to solve about that. And then we have Obsidian Live Sync. So I'm running Obsidian from all my nodes and things like that, for my personal nodes and my work nodes. And I'm using Live Sync to sync that all up to one place. I'm using Live Sync because I'm able to store a lot more files. I'm not storing that much files actually here. It's only 1 gigabyte for each. And there's no limit on the file size. So whenever I have a bunch of big PDFs that I want to put in, then I can do that. And the sync is also really fluent. It's a lot better than having files sync and then having that connected. The nice thing about Live Sync is that it works on all platforms. So I have it on my phone, I have it on my other computer, and even on my iPad, because it's all inside of Obsidian itself and not like a different file sync like OneDrive or things like that. And then we have Ubiquity. This is just to read the comics. I don't have that much comics, but to read comics through my phone or my iPad, things like that. And the next one, this is a big one, is Home Assistant. This is like my whole, this is like all of my home automation. This is all of my home automations, like lights, and also my heating system, my shutters. It even has things like my TV connected to it, because then I can push things to it, and also the lights that I have here, so you can see here. It's all connected. I also have some power sensors, so maybe we can talk about that right away. You can see here currently power use of all of the things that are connected to like the main power bar is 88 watts. And this is both servers. This is the router. This is the switch. So all in all, I wish it was a little bit better, but it's still pretty good. And I can keep this under control or have a look at it and also write down what the power use is from the whole HomeLAB stuff. Next one, there's Grafana. This is all of the data, the logging, and especially the home stuff. This is the same setup that I used to use with like a single server, which meant I can also use also have server information on it, but because it's running inside of a container, I don't have access to anything outside of the LXC container, so that's kind of useless. But the rest works here. So the sensors, CO2 sensors, electricity, that's all coming through, and I can check that. And then here we have Node Red. This is just for extra, different kind of automation and different kind of things that I want to do here. This is for the shutters. So for the shutters, I don't have an integration at all. I have to send a specific UDP request with a token that I've gotten separately. So that's kind of how I had to do this. Yeah. But it works, and it's very useful to have this all automated in this way. And I think that's it for this. One last thing to talk about is that so for this VM computer, of course, it needs to access the NAS. So the NAS has NFS, and then this is connected to NFS. And the way I've done it is that the VM Proxmox will connect to the NFS, and it is, of course, it's whitelisted. And then all of the containers that are inside it, they have mount points to that NFS. So for those containers, it acts like a storage drive. Maybe this is why I have these issues, but yeah. That's it for my HomeLAB from now on. I would love to hear about your HomeLAB or how you have set things up in the comments. And also if you have any suggestions on what I should do better, or if you have any suggestions on what kind of video you would like me to make. It could be about HomeLAB, something more in depth, maybe something about my other videos, or something that you've seen somewhere around in my videos. I would love to talk about it. Thanks for watching and have a good new year.